All right, today we are learning about the distributive property. So go ahead and, like usual, go ahead and put your name. And let's get started. So in our warm-up, okay, which expression does not have the same values as -11 plus -11 plus -11? Well, if we added 11 plus 11 plus 11, we would get 33. And these all have the same sign, which is negative. That's how we knew to add them. Now our answer is not positive 33 because you can't add 3 negative numbers and get a positive number. So our answer is actually negative 33. So we're determining which of these is going to be equal to negative 33 and which one is not. So A gives us negative 33. That one's correct, so that's not our answer. 3 times negative 33 would give us negative 33 because it's a positive times a negative. That one's good. Negative 11 to the third power. That's 11 times 11 times 11. That is not going to give us anything close to 33. That's going to give us a huge number. So that one's wrong. 33 minus 66 will give us negative 33 because the difference here is 33, and we know it's negative because the 66 is larger. And this could be written as 33 plus negative 66. All right, so Miguel measured the area of a piece of carpet and figured out that the approximate error was 3 times the absolute value of negative 0.2. What is the decimal form of that number? The decimal form. Well, first off, let's go ahead and write it without the absolute value. The absolute value of 0.2 becomes 3 times positive 0.2. Why? Because it's 0.2 away from 0. And remember, when we're taking the absolute value, it's never going to be negative. So now we just multiply 3 by this, and we get 0.6. And that would be I. Okay? What is the perimeter of the triangle shown? Remember, perimeter equals all the sides added up. So it's going to be 15 plus 9 plus 6y. Now, what can we combine here? We can combine this 15 and this 9 because they are both constants. So when we add them together, we get 24 plus 6y. And when we look for that answer, it is right here. It is A. All right, moving on. Okay, so today we are learning about the distributive property. And the distributive property is basically, if we were to, let's look at this rectangle. Oops, did not mean to write that. Let's look at this rectangle that we have here. So it's saying that this side on the left is 8. I don't know if you guys can see that. And this side right here is x plus 5. So what the distributive property says is you can find the area of this rectangle, and then you can also find the area of this rectangle, add them together, and you will get the full area. So normally it would be this side times this side, which is written over here, is going to be the same as 8 times x and 5 times 8. Okay? And we'll go over how we get that. But visually, from this rectangle, you can absolutely do that. You can split this rectangle into 2 pieces and add this area with this area. Okay? So, the distributive property, how it looks like in math without these shapes. Okay, so we've got A, B, and C. They're real numbers. And what we do here is we have A times B plus C times A times B minus C, and then B minus C times A. Each time we've got this letter or number outside of the parentheses, we have to distribute it to the inside. Okay? I'm going to rewrite this. We distribute to the inside. So all the terms get multiplied. So this becomes A times B plus a times c. Okay? Now, even if there were three values, so let's say it was b plus c plus d, okay? A gets distributed to all three values. So this becomes a times b plus a times c plus a times d. Okay? And now what these ones down here are showing is just you have to be careful when there's a negative. So this would become a times b, which is our first one, minus ac, because there's a minus here. So this c is treated as a negative. Okay? All right. So let's try some on together. All right, that's annoying. Why isn't that erasing? Okay. So we've got 3 times x plus 8. So as I said before, let's distribute the 3. So we've got 3 times x, and then let's distribute the 3 to the other term, plus 3 times 8. This is going to give us 3x cannot be simplified, but 3 times 8 we do know, and that is 24. So 3x plus 24 is the simplified form. Let's go ahead and do that for b. So we're taking the negative 7 and we're distributing it to both terms. Let's distribute it to the 5b. It becomes negative 7 times 5b. And then let's do the same with the minus 4. So now we've got, oops, I shouldn't have changed. We've got minus, because there's a minus, negative 7 times 4. Okay? Make sure this minus right here, okay, gets carried over, because that's going to make a big difference. Okay, so now we can go ahead and solve this one. Negative 7 times 5b becomes negative 35b. Remember, we can multiply the negative 7 and the 5 and leave the b by itself. Okay? And that becomes negative 35b minus negative 7 times 4 becomes negative 28. And now we can simplify this even more. See how we have a negative and another negative? We can make this negative 35b, change this to plus, and then use the opposite of negative 28, which is positive 28. Okay? Now, the reason we cannot simplify it, just like we couldn't simplify over here and over here, is because one term has a variable and the other one does not. This 28 has no b next to it, so we cannot combine those any further. That's how we know we're in its simplest form. All right, and we've got 7x plus 2 divided by 5. Now, this doesn't look like it's the distributive property right now, but I will show you how it is. So we've got 7x plus 2 as the numerator, and our denominator is 5. So we can rewrite this as 7x plus 2 divided by 5. And remember, if we were thinking about this like it's a fraction, we can say 7x plus 2 over 1. Remember, keep, change, flip. So we've got multiply by. This is the same as 5 over 1. So this becomes 1 over 5. Oops. 1 over 5. So now we've got 7x plus 2 times 1 over 5. So then this turns into 7x plus 2. And we can just add the 1 over 5 outside. And now what we do is we distribute. So let's distribute the 1 over 5 to 7x. This becomes 7 over 5x. And then the 1 over 5 to the plus 2. This becomes plus 2 over 5. Basically, what you guys need to know is this 5 as a denominator, a denominator can be distributed to both terms. So basically what we did was we took the 5 and we put 7 over 5, and then we did 2 over 5 from our original, okay, if you're comparing them. We will do more examples of this. I know it's not super clear right now, but you should get an idea of what to look for, okay? This 5, or the denominator, needs to get distributed to both terms. What is the simplified form of negative 2y minus 3x? Another thing that you guys will see with the distributive property. This negative sign, okay, we are going to treat it as negative 1, okay, times 2y minus 3x, okay? So then we can distribute the negative 1, and we get negative 2y minus, see how it's minus inside the parentheses? It has to be minus outside. And then it's negative 1 times 3x. Actually, I'm going to rewrite this portion. So I want to rewrite it for my sake. It was in blue. It's going to be negative 1 times 2y. Because I want you guys to see that it's negative 1 getting multiplied by each of the two terms inside. All right, so what we are left with is negative 2y minus, this becomes negative 3x. So negative 2y, we change this to plus. The opposite of negative 3x is positive 3x. And this is our simplified form. Okay, so that negative sign outside gets distributed to both terms as a negative 1. All right, vocabulary. So a term is a number, a variable, or the product of a number and one or more variables. Go ahead and highlight the term. That's not a good highlighter color. Darn it. Maybe red. Okay, that looks better. Okay, so a term. All right, if you look down towards the bottom, 6a squared, negative 5ab, 3b, and negative 12 are terms, okay? They each are separated by an operation, okay? I would like you guys to add that in there. Separated by an operation. Okay, a constant, so let's go ahead and highlight constant, is a term that has no variable. So this constant down here would be negative 12. It's the only constant, okay? Why? Because there's a b in this term. You're not seeing what there's a b here, there's an ab here, and there's an a here, okay? None of those are constants, okay, because they all have variables in them. All right, a coefficient. Coefficient is a numerical factor of a term. So coefficients would be 3, negative 5, 6, because they are the number portion of a term, okay? And then like terms, they have the same variable factors. So in this case, a squared, ab, and b, none of them are like terms, okay? So we're gonna go ahead and fill that in. If we had 7, ooh, I don't wanna write in a highlighter. If we had 7a plus negative 3a, these would be like terms. Okay? Like terms can be combined, okay? All right, so let's go ahead and do some practice. We got 8x squared plus 2x squared. So what's in common is this x squared. That's our term. That's part of our term. So what we can do is we can write it as 8 plus 2, and then the x squared, which is in common, comes outside the parentheses. We all know what 8 plus 2 is. That is 10x squared. Okay? All right, let's look down below. We've got 5x plus minus 3 minus 3x plus 6y plus 4. So in one color, I'm going to box in 5x. I see that we have a minus 3x. That can be combined with the 5x. There's nothing else with an x in it, so let's move on to a different color. We've got negative 3, and that's just a constant. The only thing that can be combined with the negative 3 is plus 4 over here. Why? Because both of them are just numbers. They have no constant, or no variables. And lastly, we've got plus 6y. So let's use a different color for plus 6y. So now let's go ahead and combine our green colors. So that's 5x minus 3x. That becomes 2x. Actually, I'm going to write it all out. Sorry. That becomes 5 minus 3. The x outside. Our red becomes plus negative 3 plus 4. And then our blue stays as plus 6y. Okay, so this becomes 5 minus 3, which is 2x. Negative 3 plus 4 becomes 1. And then this becomes plus 6y. That is our simplified form. All right. Now, in the book, traditionally, you write the terms with variables before the terms without. So this will probably be written as 2x plus 6y plus 1. Either of them, they're the same, but just so you guys know, that's the standard for writing it. You write the terms with variables in front of the terms, like the constants. So the plus 1 would come at the end. Okay, 8x squared minus 2x to the 4th minus 2x plus 2 plus xy. Can we simplify this? The answer is no, and I'm going to explain. It's no because they have no like terms. This x is squared. This x is to the 4th. There's no other x squared or x to the 4th. This x is alone, and this x is with a y, and this term is a constant. Okay? So when you have no terms that are identical in terms of the variables, the 2 has no variable, the x, there's an x, there's an xy, there's an x to the 4th, and there's an x squared. We cannot simplify it, so no. This is the simplest form. Okay? All right, let's move. So now we've got some practice for you guys. So go ahead and pause the video. I want you to try this slide. Go back and play the video, and then it'll go over it, okay? So we've got 3 times 0.4, which becomes 0.4 times 3. And then we've got 3 times 1.1c, which becomes plus 3 times 1.1c. So this becomes 1.2 plus 3.3c. D, we can distribute the negative y. This becomes negative y times 2y. And then distribute the negative y again. It's minus, because of the minus in here. Negative y times 1. Okay. So then this becomes negative 2y squared, because y times y is y squared, minus plus y. These cannot be combined because one is y squared and one is y. 15 plus 6x divided by 12. Remember, we can distribute this bottom term to both terms up top. So this is just going to be 15 over 12 plus 6x over 12. Okay? We proved how we did that in one of the slides before this. Okay? So remember back to that. Now, we do have to simplify. So 15 divided by 12. What's in common? Well, they both have a 3. That will cancel. And then 6x over 12 is also 6 times 2. These will cancel. So we're left with 5 over 4 plus x over 2. That is our simplified form. 4 minus 2x, this is going to be the same, so we're going to distribute it. So it's 4 over 8. I'm going to use a different color, sorry. It's 4 over 8 minus 2x over 8. Remember, we proved that with the slide before. Okay, so now we've got 4 over 8 is 4 over 4 times 2 minus 2x over 2 times 4. So what we're left with is 1 over 2 minus x over 4. And that is our simplified expression. And the next slide on your, I want you, next page. Julia commutes to work on the train 4 times each week. 4 times, oops. A round-trip ticket costs $7.25. What is her weekly cost for tickets? Use mental math. So she commutes to work on the train 4 times each week. A round-trip ticket costs $7.25. What is her weekly cost for tickets? What do you guys think we should do? We should multiply them. So we should have, if she's traveling 4 times per week, a round-trip ticket costs $7.25. We should end up with $29 as her weekly cost. The next 2 slides on your own, and then we will, what is the simplified form of the following? So we've got 3y minus y, and these are like terms, okay? They both contain y, not y squared, not y cubed, but y, so we can combine them. So 3 minus, this becomes 3 minus 1 times y. Remember, there's an imaginary 1 in front of that second y. So if we wanted to put that in there, okay? That way you guys don't get confused. 3 minus 1 becomes 2y. That is the simplest form. And the next one, we've got negative 7mn to the 4th minus 5mn to the 4th. Mn to the 4th is in common with mn to the 4th. Therefore, we can combine them. So it's negative 7 minus 5, in parentheses, mn to the 4th, because they are like terms. This becomes negative 7 minus negative 5 is negative 7 plus. The opposite of 5 is negative 5. So now we've got negative 7 plus negative 5. 7 plus 5 is actually 12. We know it's negative 12 because they're both negative. n to the fourth, 12 n to the fourth. This is our simplified expression. All right, good luck. You guys have some homework, and let me know if you have any questions. Bye.